So by now, with all the math that we've done, we should have come around to expecting that math is going to be a little particular at times. And when it comes to exponents, this is definitely one place where mathematicians can be particular. Specifically, we don't like negative exponents. So anytime we come across a negative exponent, we're going to be forced with simplifying an expression to get rid of the negative exponent and essentially to convert it to a positive exponent. So that's what we're going to be doing here. That's what we're going to be doing today. So we're going to convert all negative exponents to positive, and just for the practice, if we need to, or if we come across a numerical base, and by that I mean a power that has a number making up its base, just for the practice, we're going to evaluate those bases. So what's going to make this a lot easier is for us to accept that any exponential expression, any expression made up of powers, is essentially a fraction. If it's not already in fraction form, and lucky for us that 1, 2, 3 of these are already in fraction form, if it's not already in fraction form, then we can simply turn it into a fraction by taking whatever our power is and writing it over 1. The reason why I want us to view these expressions in fraction form is because when it comes to negative exponents, we're going to look at the location of where the term is that has a negative power. And we're simply going to move it from where it lives as a negative exponent to the other location within the fraction by converting it to a positive exponent. So essentially, if I were to look at this first example, I see that x to the negative third, if I think of that as a fraction, it's all over 1. This power is hanging out in the numerator as a negative exponent. And the way that we simply convert that to a positive is we take that, x to the negative third, and we move it to the other location in the fraction. And what that's going to give me now is x to the third in the bottom, which is essentially multiplied by this 1, but we should all know that 1 times anything is that anything. So when we brought that x to the negative third down, we got that 1 times now x to the positive third. That's how we convert from a negative to a positive exponent, move it, in this case, from the numerator to the denominator. But what do we do in the numerator now? Well, we have to think about a placeholder. Since we lost that term in the numerator altogether, we just simply put a 1 there, and we're done. Now, there's nothing more for us to do here because of the fact that we don't have a numerical base, we have a variable base. So this is our final outcome. In the next example, it looks very similar to this first one, except this time our negative exponent is in the denominator. So sticking with the process of moving it from where it's negative, in this case in the denominator, to the other location in the fraction, we're simply going to bring that 2 to the negative sixth, move it up to the denominator. I'm sorry, move it from the denominator up to the numerator. And you could argue again, since we're losing that denominator altogether, we have to have a placeholder of 1. But in this case, anything over 1 we can just write as the anything by itself. So there's our 2 to the sixth. We took our negative exponent, our negative power, and to convert it from a negative power to a positive, we moved it, in this case, from the denominator up to the numerator. Here, though, we do have to also evaluate. So here, we have to recognize that 2 to the sixth is nothing more than 2 times 2 times 2 times 2 times 2 times 2. Again, that's an example of a product, so don't forget the vocabulary there. By the time we're done, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. One more time, times 2 is 64. So my evaluated outcome is 64. My simplified outcome as a positive exponent, 2 to the sixth. So if we can accept that it's a simple process of moving something negative in a fraction to its other location in the fraction and turning it positive, then something like this next example should be fairly straightforward. We're going to take a look at this, and anything that's negative, like the a to the negative sixth is going to move. So the a to the a to the negative eighth is going to have to move downstairs from numerator to denominator. B to the negative third is going to have to move upstairs to convert to positive, and the c squared is perfectly okay. So I actually like to leave what is in its proper place where it is. So my c squared, my b to the negative third goes upstairs and becomes b to the third. My a to the negative 8 moves downstairs and becomes a positive power a to the eighth. So by the time we're done, we have b to the third over a to the eighth, c to the second. And one little thing I want to point out, anytime you have multiple powers with multiple variables, the general rule is we will go alphabetical. So that's why we have the a coming before the c in our final answer in the denominator. A alphabetically comes before c. So this is your final answer. Okay, so this last example was pretty straightforward because our terms were all different variables. Sometimes, though, we're going to notice that our numerator and denominator share the same base. So I want you to think about this as really nothing more than 2 to the 7th over 2 to the 4th times 5 to the 11th, 5 to the 11th over 5 to the 15th. Now, these are both situations of quotient rules. So we know quotient rules, we should be subtracting down, subtracting down. So if I were to just focus on the 2 to the 7th over 2 to the 4th, I would get 7 times 4 is 2 to the 3rd. Likewise, if I were to subtract down for the other quotient piece, 5 to the 11th minus 5 to the 14th, if I were to subtract down, I would get 5 to the negative 4th. And then I would have to deal with the 5 to the negative 4th because it's negative and move it essentially downstairs in our fraction. Again, think of all of that as one, move it downstairs. Okay. Now, another way that we can approach this, and the way I want you to get used to this, is instead of subtracting down, in this case, because I have a larger exponent and as a product I have more 5's in my denominator than I do in my numerator, then I want to get in the habit of subtracting upwards, because by the time I'm done, I'm going to have some leftover 5's here. So subtract in a way if you can so that you will be guaranteed to get a positive exponent. So essentially what I'm saying is, if we were to go back, I could do 2 to the 7th over 2 to the 4th. 7 minus 4, subtracting down, is 2 to the 3rd. I subtracted down. But likewise, when I go the other way, 5 to the 11th over 5 to the 14th, 5 to the 14th, I'm going to subtract up because I have more 5's. I have 4 more of them. I'm sorry, 5 to the 15th. I apologize, 5 to the 15th. 15 minus 11 is 5 to the 4th. So by subtracting my larger exponent minus my smaller, and whatever I get as a leftover, I'm going to park that where the larger amount is. So this is it, 2 to the 3rd over 5 to the 4th. Now, one more time, we need to evaluate. So when we evaluate, we're going to get 2 times 2 times 2, that's 8, over 5 times 5 times 5 times 5, 5 to the 4th, that's 625. So this is our final simplified expression with positive exponents. This is our final evaluated expression because I have numerical bases. So one more time, I can't emphasize enough. When we subtract, if we have common bases, both numerator and denominator, get in the habit of subtracting in a way that guarantees you to get a positive exponent. So I had more twos in the top than the bottom, so I subtracted down, and whatever my difference was stayed where I had more in the numerator. With the fives as my base, as my common base, I subtracted up, and my leftover four I placed in the denominator where I had more to begin with. So that is everything related to negative exponents. We're not going to worry about the rule because I want us to try to strategize together in our discussion and see if we can come up with a sufficient rule. And then we will get some practice in. See you soon.